You all and many have come to tour the Hoover Dam, even though it is no longer the tallest dam in the world, rather because of the incredible contrasts it has come to represent. The Hoover Dam is well known as an ambitious construction project accomplished during the Great Depression of all times. It's also well known as having brought to the water to the desert of all places. And out the window here, we see another of these contrasts. Out there, you've got the Colorado River flowing through what was once solid canyon wall. I will be using my diagram up front here to explain how all of this has come to be. And you can think of the construction of the Hoover Dam as having occurred in three main parts. To put this simply, we first moved the Colorado River out of the way, to then second, built the Hoover Dam, and third, we put the river back to fill in the lake. So the first step, if you are going to move the Colorado River, you need to have somewhere in particular for it to go, and to that end we built 4 50-foot wide diversion tunnels like the one we now stand inside. We then had to get the river moving through this tunnel. You see the original path of the Colorado prior to the lake being here, outlined in these dashed lines here. We've got to move that into the tunnels, so we built 2 temporary dams before the Hoover Dam. These are called coffer dams. The upper coffer dam is what actually gets the water going into the tunnels, while the lower coffer dam serves to prevent backflow of water into the construction site. So that between the 2 coffer dams, we've got dry riverbed, a nice spot to start our second step, building the Hoover Dam. That begins by digging down from that riverbed down to bedrock, serving as a solid foundation for the project. 9 cableways were then used to bring down concrete to that level. That concrete was poured into wood forms so we could assemble the dam bit by bit rather than all at once. This is done to optimize the setting of all of that concrete, and indeed it takes only around 2 years from the time of the first bucket of concrete poured to the last one. This is especially incredible when you consider that the Hoover Dam required 6.6 million tons of concrete for its completion. And with all of that poured and set, we built the dam. We're ready to fill in the lake behind it. That third step starts by removing the lower concrete. You can see it would pretty clearly be in the way. Otherwise, the solution to that, quite simple. We use dynamite, blew it up. The upper one, easier to handle than that. We left it there. Lake Mead has filled up and over it. The upper coffer dam is underwater. So we've got to get the water out of the diversion tunnels and filling up the lake. In order to accomplish that, we plug those tunnels up with massive concrete plugs. These are placed in all 4 diversion tunnels, but the plugs in the outer Nevada tunnel are installed with valves. This allows us to regulate the flow of water going downriver while Lake Mead is being filled. Once it hits the appropriate height, those plugs are permanently sealed like the rest of them, and that leads the Colorado to flow the way it does today. So now the water comes down the river and then enters into one of 4 of our intake towers rising out of the lake. Those intake towers connect to our penstocks. We're standing above a penstock out the window. So you know in this case, when I'm saying penstock, I am referring to a 30-foot wide pipe. On the diagram, you are there above that particular section of penstock. So you know then that the water we're hearing beneath us is eventually being shot into the turbines to spin up the generators we're about to go see. You would imagine then that this can move through quite a lot of water. You'd be correct. All 4 of our penstocks together at full capacity can move past the Hoover Dam 2 acre-feet of water every second. If you're curious as to how much that is, imagine 2 American football fields with a foot of water on top of that, getting through those tunnels every second. Now, if we have more than that coming down the river, we have a backup plan, because we cannot allow water to go over top of the Hoover Dam. That backup plan is our spillways. We have one on the Arizona side and one on the Nevada side. These automatically take on the water that would go over top of the dam, and instead there is a connecting tunnel from that spillway entrance over the tunnel plugs, and then that water just goes safely down the river. Now, fortunately, we have only ever had to use these spillways all at one time. In 1983, we see that pictured over here. So this is the Nevada Spillway in operation. You also see in this photo the high point for Lake Mead. In 1983, the top of the lake came within 7 feet of the top of the dam, but no higher than that, so spillways work. And now you know those 3 steps, how we built the Hoover Dam. First, moving the river out of the way. Second, building the dam. And third, filling in the lake behind it. Up next, we'll be heading to the power plant. Please just let me get out the door first, and then follow me right next to your friends and family. Have you head on into the elevator?
As you can see, we got one coming out, one going in. Where are you guys from?
Welcome in, everyone. You can find any. Here we have another of these incredible contrasts created by the Hoover Dam. In front of you, mankind bending nature to make some light in the dark. And what is really incredible about this renewable hydroelectric power is that this is, in a way, what makes building the Hoover Dam possible. See, it was agreed that in order to pass this project as an act of Congress, that it would have to pay for itself. And that's why we have a power plant. The power plant is included to raise revenue and pay back the cost of building the dam. It accomplished that with the revenue made here as of 1987. You then are probably more so curious about what all is going on in front of us now. We'll be addressing that. We are looking at 8 out of 17 commercial generators contained within the Nevada wing. The remaining 9 are some ways behind me in the Arizona wing. Each one of these makes up to 130 megawatts. Altogether, that is enough to serve the needs of around 1 million homes. And we can get some sense for just how it is that's possible as we look at the operational generator N1, or Nevada 1. Look at the center of that generator. You'll see the silver shaft of that generator's rotor. Attached to that shaft is a wheel of 40 quite large electromagnets. These are just behind the red housing. By spinning those magnets around, we are exciting electrons, and then out of that generator goes electricity. Now, that spin is the result of the part of the generator. That generator goes down 40 feet beneath the marble floor. That's where that part is. The part down there is referred to as the turbine or the turbine. So when we say that word, turbine, we are not talking about the whole generator. The word turbine refers just to the part that looks like a water wheel. So water is shot out from the penstock we were standing on before into the blades of that turbine. That turbine is then spinning the rotor that you see there. As we look down the wing, it is only the generators with the indicator light on top of them lit up that are actually operational. So this would be generator N1 and N7. Inside those 2 generators, the rotors are spinning around at 3 revolutions per second. Now, if we look down, we'll be able to see one more indicator light lit as well. This would be generator N0. So the rust and color generator that's kind of on its side, sticking halfway out of the ground, that is also operational. This is one of 2 of our Pelton water wheels. We have another one in the Arizona wing. Each of these makes 2.4 megawatts, and that power stays here and is used at the Hoover Dam. The larger generators, those make the power that is sent out and sold to various cities in the western United States. Some examples would include Las Vegas, Los Angeles, or Phoenix. In fact, generators N1 through N4 make up the very first circuit of generators to be installed all the way back in 1937. So yes, you are seeing a generator operational here that was installed in the 30s. For the first 50 years, the power made there was contractually going to Los Angeles specifically. Now, in order to maintain these generators throughout the years, and they are all original from whenever they were installed, we have the green bridge cranes that you see at the top of the wing. Those cranes can move along the tracks you see on the sides here, and those cranes then can be combined together over a particular generator. When they are combined, they have the necessary 600-ton lifting capacity that we need to lift up the rotors inside those generators and perform maintenance on those. Now, the length of the wing that these cranes can move along is roughly 660 feet long. I round to that number as it happens to be the thickness of the wall of our dam at its base, 660 feet front to back. Folks, that wall is behind you, just past the benches. So if you imagine the length of this wing filled in with concrete extending out that direction, you will leave today with a fairly accurate appreciation for the enormity of the Hoover Dam. And it is time to leave. This is the end of your power.
If they died or being dragged off the property or they got the Boulder City Hospital, they didn't count them.
Oh. I know it's mostly from like.
See, I wanted to know that. 96. Hooverdam.